Hello, everyone. Thank you for joining us. My name is Hana Kim. I'm the director of the Cheongdong Station Library here. Before we begin, I'd like to take a moment to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. Thank you. So, welcome to the very first event in our AI innovation series. We are excited to have you with us today as we explore the fascinating intersection of AI and classical Chinese studies. This series has been designed to support our community in navigating our roles and responsibilities while effectively integrating AI into our daily work and special projects. Our goal is to raise awareness of various tools and approaches that can enhance our scholarship, particularly within East Asian studies, related disciplines, and East Asian librarianship. We also aim to discuss potential strategies for integrating these innovations into our research practices. Today marks the launch of this series, and we are already planning our next event for early 2025. It will include hands-on workshops where we can further explore into how AI can be integrated into our work and research. Now, I am delighted to introduce our special guest speaker, Guenther Lomas, the founder of Sigtica. Guenther will share his insights on how AI is transforming the landscape of classical Chinese studies. As an expert in document intelligence, he will explore innovative methods to enhance research capabilities and uncover new insights into historical texts and cultural narratives. In his talk, Guenther will demonstrate how AI technologies can transform large volumes of unstructured classical Chinese texts, such as genealogies and records from Qing Dynasty government employees, into organized and searchable databases. This innovative approach addresses the long-standing challenges of manual data entry in classical Chinese studies. We also hope that Guenther's sharing gives us the opportunity to explore how what we learn today can potentially be applied to either other languages like Japanese or Korean or even Tibetan. Guenther is a proud graduate of the University of Toronto, where he earned his PhD from the Center for Industrial Relations and Human Resources. He is the founder of Sigtica, specializing in document intelligence and transforming unstructured data into structured databases. His work focuses on applying AI technologies to the digital humanities, particularly in quantitative history and cultural heritage preservation. His latest project involves collaboration with the Lee Campbell Research Group at the Hong Kong University of Science and Technology, where he is utilizing Qing Dynasty employee record data to develop tools for digitizing classical Chinese texts. So without further ado, please join me in welcoming Dr. Guenther Lomas.
Thank you for that wonderful introduction. I was a little embarrassed to hear it myself, but yes. So my name's Guenther Lomas, and Sigtica is actually a company I run that does digital humanities, and we've been working with universities in the Asia Pacific and also North America to digitize large amounts of content. And so today I just wanted to just share with you what we've been working on, get some feedback on some of the work that we've done, and have a discussion about the pitfalls of digitization and what we should be aware of, and all that to improve the overall technology so that everybody can benefit from that. That's pretty much what the theme of this talk is. So first, just the background about Sigtica. So the name Sigtica actually the logo was actually based on a normal distribution from statistics. So it actually becomes 4 normal distributions in a XY quadrant. And the reason why we did that was because that's a tribute to statistics, and AI is actually applied statistics because you look for patterns in data. And so that's actually what drives my entire team's ethos, is really in this. It's really about using AI or applied statistical methods to try to identify patterns and digitize large amounts of content at an affordable rate, which is actually quite challenging, it turns out, in AI. And so we've been very lucky to work with HKUST, the Lee Campbell Research Group, in using their data to train OCR models and to learn how digitization could be done on classical Chinese text, which also might be applicable to other kinds of languages like Japanese and Korean as well. Right, that's about that. And this is just my team. We have a core team. There's a bigger team too, but we are essentially a bunch of data engineers, and we think of ways to engineer solutions to try to extract content. I think this slide is pretty interesting. So document intelligence is when you start off with a PDF file, a scan of some sort, and you have, say you have a document here with a title, a description, table, footer, some sort of content on the page. And so you can actually visually look at that and say, okay, yeah, I understand what the title is. I understand what the description is. As a human, you've gone to school, you understand that. But for AI, if you don't tell it that, then it's not going to know that. So you have to kind of tell it, oh, yeah, this is the title, and you tell it many times, and it's able to learn. And so visually, when we look at a document, the position of where the words are actually have different meanings. If this word was actually on the bottom of the page, we would interpret it as a footer or a page number rather than as a title, right? Or big font, small font. These are clues that we understand as humans as to what is on the page and how to interpret the content. And we have to tell AI that in order for it to actually understand. The second thing to consider is the context. So here's an excellent one. Apple the fruit or Apple the company. And if I just showed you Apple without any context, you probably couldn't tell. I'm going to talk about fruit or companies. But with context, you can then kind of figure out that, oh, okay, it's talking about the company. And so both contextual and visual clues gives us a lot of information to go on to be able to extract content. We need both in order to be able to do the final prompt, which is the structured data. And so by structured data, that means databases. And we're all very familiar with databases for research. Usually when we go to the library, we search on databases to find content that we need. So meaning that if we're able to take the visual clues and the contextual clues and create a database, that would be extremely helpful for research. And right now, that's a bit of a bottleneck for some of the content. Some of the content is not searchable, even though it's been scanned. So here's just a representation of that. Let's say 20 years ago, we only had hard copies of Explorer. Sorry. So 20 years ago, we had hard copies of books. And so that means you would have to actually go physically into the library and look at a book and take it out. And that means when you take it out, no one else can see it. And that worked back then. And then later on, there was a large digitization effort by different libraries across North America on scanning the content. So you would just take the book, scan it, and then you put it in a database, and now people can search this. It's been indexed. You have the titles and all that. But say you want to look for a very specific idea in a book that mentions a very specific term. Then you would actually have to read the book, even if it's a scanned copy. You'd still have to go through each page and read it before you would actually be able to find your content. And if you didn't bookmark that page, then you would have to do it again next time you look. But this is where we are right now. So we've already passed the hard copy stage, and now we're in the scanned phase. So that means that a lot of the key collections at different libraries are usually scanned and available in some sort of format. Where people want to be, and this is just based on my conversations with many people, is we would like to have searchable text. Here's the image, and we want the companion text next to it in some sort of structure. So in this case, this is just an example. This is a Chinese genealogy book. There's these big fonts and small fonts, and the big fonts are names. So then in this column, these are, the column would be name. And then the smaller fonts are descriptions of these people, and that would be in a separate column in a different cell. And you can already see how this is really handy, because then you can search across okay, I just want to look at a specific character that appeared in people's names. I'd be able to do that in this spreadsheet, but I wouldn't really be able to do that in a scanned picture. Similarly, if I only wanted to restrict my research to understanding content about the person, the description, I would also be able to do that in this context. So the idea is, how do we go from scanned to searchable text? That's where we've been trying our best to create some sort of AI solution to do that. Yes. And so, well, ChatGPT has become my best friend now. I'm sure a lot of people have tried this. And so the first question is, well, can generative AI solutions do this? Can we tell ChatGPT to digitize the content and we're ready to go? So we tried that, actually. So the first thing we did was, so in ChatGPT, because it's generative AI has a few pitfalls. First of all, it's stochastic, which means if you ask it the same question twice, it may or may not give you the same answer twice. In fact, sometimes if you ask it, are you sure, it'll then change its answer, and then you get something completely different. If you use the API version, you can actually create a context. So up here, we have a context. What we do is we tell ChatGPT, this is the background behind the image that we're about to show you. And so in this case, we tell it, you are a Chinese historian, and you are good at reading and understanding genealogy. So we're trying to give it a heads up. Please think in terms of Chinese genealogy. And then we give it a prompt. So the prompt is essentially like we're telling it what to do. So we're saying that we're giving it more content. We're even giving it clues. We're saying there's 5 rows on this page. So 1, 2, 3, 4, 5. There's 5 general rows on this page describing it. And we tell it something about the way to interpret it. And we even tell it larger font means some sort of relationship, and it means a person's name. And so essentially, we're trying to give it, as if you would tell a student, okay, this is how you should interpret the page. Can you extract it for me? Can you turn it into a CSV file? So that's essentially a spreadsheet. So it turns out, actually, it kind of works a little bit. If you tell it enough information, it's able to turn it into, so we asked for 2 different spreadsheets, mainly because the nesting of the data is slightly different. And so the first thing we asked it for was person-level information. So that means name and the biography. So that would be like the name and the biography. And it's able to actually OCR some content, but it's not very good. And then the next thing we asked it was, can you also kind of link the parent and child based on the way that we had described it, based on the X and Y coordinates of what you see visually? It can kind of do it too, actually. It's actually quite surprising. It can actually do it, but it's not quite ready for research or for database searching, because it makes a lot of mistakes and you have to put a lot of effort into teaching it. But it's a good start. So actually this is actually a Korean genealogy that we found, and we did the same thing. And it was actually also able to extract some of that content as well in a similar way. So it's not quite ready yet, but it's possible. Then we also tested other languages too, like this would be a collective agreement from an Ontario union. And we asked it to, so here, actually, in fact, even though it looks different visually, actually, contextually, it's very similar. So in a legal document, you usually have different clauses, right? And certain clauses are nested under different sections. So there's some sort of way to interpret it, right? This is Article 3, and then this is Clause 3.01, 3.02, and so forth. And so we tried to do the same thing. And what we noticed was that from a human's perspective, you can, if you look at that, you can read it clearly. It's very clear what the text shows. But actually, we noticed that the content that comes out of it is sometimes misrepresented. So sometimes ChatGPT might take half of this sentence and plug it in a different paragraph. So then we have a problem of data quality, because, well, what if ChatGPT makes a mistake? We can't find that if they're plugging in half a sentence. They're essentially creating a new sentence based on different pieces of different sentences across paragraphs. So that's going to be a problem. And at the moment, we haven't found a solution to being able to control ChatGPT in this area, which is why we think that generative AI is useful, but also is not quite there yet. But it does show some sort of promise. And I would say that a lot of effort has to be put into prompt engineering, but even then, it's still very difficult to be able to get exactly what you want. And then, so this one's actually quite a challenging one. So this is Japanese calligraphy. Calligraphy is always much more challenging than printed text. And so we told her the same thing. We said, you're a Japanese historian and you're good at reading ancient Japanese manuscript. Now, of course, we didn't put a lot of effort into the context. Maybe if we told it like a super long story, it would know more. And we just asked, can you convert it into text? I can't read Japanese, but I recognize the first character. I don't know, I think that's correct. And only the characters that I recognize seem to be kind of correct. At least what it shows is that there's some hope here that ChatGPT might be able to extract some of your content. I just want to note one thing though, is that this format is very simple because it's just top down, right to left. So ChatGPT can figure it out. We'll just have to keep on reading this way and we'll be able to digitize all the content and put it into one big paragraph. It's a lot more difficult when there's different kinds of positions and different tables on the page. And lastly, this is another one that we tried. So this is a customs data from China in the Qing Dynasty. And actually, a lot of people attempted to digitize this. Actually, it's much more difficult than it looks. We would have thought that by now you could extract tables from PDF files very easily. Actually, it turns out it's not that easy. And the reason why is because of these kinds of things. So you see there's like a vertical line here. Sometimes it's really close to the number, and then you get misrepresentation of numbers. And that's going to be a big problem if the number matters. Imagine if you had missed a different decimal place or had a different digit, then that would really mess up the whole data set. And so it's really these kinds of quality issues where we think that ChatGPT is not quite ready yet, but does show some promise for probably future development. So this is just the result of that page. We looked through every single cell, and there are some mistakes. So then how do you solve this problem if ChatGPT can't do it out of box? So we thought really hard about this, and we realized that actually we need something called a pipeline. So a pipeline is a sequential process where you break it down into pieces and you apply different kinds of AI models to control quality so that it doesn't start creating sentences across paragraphs, for example. If you give it one paragraph at a time, then it cannot mash the different paragraphs together because it's only seeing one at a time, for example. And also another thing is that what really matters is the kinds of domain-specific data that you feed into it. So if it's looking at Japanese calligraphy, it needs to see some examples of what is good Japanese calligraphy, what is the correct answer, and then it's able to guess. But if you don't tell it that, then it's really making a guess based on a pool of knowledge which is really averaged out across different time periods, different kinds of calligraphy types, and that could really be very time-consuming to try to fix it after the fact, rather than building a clean pipeline from day one. So I'm just going to skip over to, okay, yeah. So what we've done in the last year is that we've been working with the University in Hong Kong on digitizing Chinese content. So this is actually a picture from Harvard Yencheng, open sourced from something called the Jinshen Lu, which is from Qing Dynasty. And it's just a record, it's just government records of different people on different government positions at what time and all that. And so when we look at this, actually it does look quite straightforward. It's top down and then right to left. But then if we look a little closer, well, it's just very dense, but density probably wouldn't matter too much to a computer because you can always zoom in and chop it up. So if we take a closer look, oh, sorry. Actually, wait, before I get to that, we've also looked a little bit at Korean and Japanese, but what I wanted to point out here was that the formatting, apart from the character, the formatting looks very similar. And so that actually plays a role in how difficult or easy it is to extract. And same thing with Japanese. But I'm just going to focus first on the Chinese content. If we look a little carefully, we'll notice that there's two characters here, and then there's big characters here, and then there's two mini columns here. And you see, the column isn't consistent, and also the background isn't consistent. Sometimes it's a stamp, a black background, and sometimes it's a white background. And so this actually starts to create a lot of challenges for AI, because AI recognizes things visually and contextually. So visually, it's already starting to get confused, because if it's seeing this for the first time, it doesn't know what the correct answer, it doesn't know that this is, if you flip the colors, it wouldn't know what the equivalent is. It wouldn't know, so this is yuan, but then if you flip the color, it wouldn't know that unless if you showed it many examples. So then what we have to do here is we have to start breaking down the layout into different segments. So we'd have to train a model just to identify stamps, train another model just to identify mini columns, train a model to identify big font and small font. We have to do all that to tell it what it's working with. This is just the zoom in of the multi-column problem. And I'm going to show an example later on how OCR is able to deal with that. But actually this multi-column problem, based on the conversation I've had, is actually a major problem in why they cannot currently use existing OCR solutions to solve this problem. And before I get to the specific OCR technology, we also worked with some genealogies as well. And this one is a little cleaner. It's a nice white layout, top right, big font, small font. This one's a little bit easier to understand. So I think the question is, if you're starting to digitize content, do you just say go to Google OCR and just run everything Google OCR? That's one possibility. But what we found was that actually doesn't work out very well. And what we really need is to understand different kinds of layouts and then group those layouts first, and then build a model which is good for that layout. So meaning that, so for example, we dealt with a large amount of genealogy data where there were many, many different types of layouts. And we realized that what we had to do first, going back to statistics, is we had to run a random sample. We had to first, out of tens of thousands of books, we had to randomly pick books and then actually visually look at them and think what kind of layouts there are. And so we have, for example, this is a layout, type 1 layout. We started labeling them as different types because they look different. So this one looks different from the previous one, and so on and so forth. And as the list went on, we started realizing there are actually many, many layouts. And so then we realized that actually one size cannot fit all. So if AI is going to fail, then clearly one size is not going to fit all, and you're never going to be able to digitize anything. Then we're stuck. So what we did was, after we looked at all these layouts, we documented them, we did a random sample, and then we came up with a distribution. There's many of them. Okay, sorry. Yeah, and then what we did was we were looking at, okay, in this pool of documents, what are the most common layouts? And we looked at, there was a layout 1 and a layout 2. That was the vast majority of all the genealogies that we were dealing with. So then what we realized is that we can't digitize all the genealogies all at once. We have to do them strategically in batches. And so we decided then to create an AI pipeline that was optimized for layout 1 and layout 2 separately, and then leave everything else. And at least what this meant was that we would have a digitized content at the end. Because if we pull them all together and we try to brute force train an AI model, it would not be able to pick up anything, kind of like ChatGPT. It would figure out some stuff, but it wouldn't be able to figure out everything else. Because ChatGPT is a generalized model. It's not highly targeted at the layouts, and so it's not going to give you research quality data. So that's the difference between, let's say, like a toy and actually a professional product is that part. So what we did was we broke down, so this is the government records from the Qing Dynasty. We broke down the page into, first of all, 2 parts, and then we broke them down further into columns. And we also did the stamps separately. And so by breaking them down, we were able to train AI models to look at them separately. And essentially what we did was we did a divide and conquer strategy. Split them up like puzzle pieces, and then we're going to piece them together at the end to create the final data set. And so ideally what we want is a final data set that's a spreadsheet. So here's the entire process, which actually has worked really well. So we've done this for multiple different kinds of layouts. Is usually start off with raw PDFs, which are unsearchable, and then you'll understand the layouts, like that really boring process of sampling, visually inspecting, and then we came up with 2 layouts. And then we'll do an OCR. In this case, we'll do a custom OCR, and I'll show you that in a second. And then we would recognize keywords here that would then be able to be split into different columns. And this is the most important part, because this is how you filter your search. It's based on these extra columns. So there's at least a few major steps here that have to be taken in order to be able to actually build a database. Layout 1, layout 2. And in addition, we also had to tell it how to understand the layout, right? And so we would have to give it examples of how they're linked across the rows on the layout. And so again, that's another model. So there's actually multiple models that go into some of the work that we do. But Well, okay, so what we did was, we were thinking just like ChatGPT, we're thinking, well, can Google OCR the content? So we actually just took this whole page and we fed it to Google. This is actually the result from Google. So you can actually try their OCR online in the browser. And what we got was, you'll notice that Google is picking up some characters, but it's missing some others. And it's kind of unable to figure out the different rows and all that. And so from this is essentially not usable data. We concluded that there's no way that we could use this in a spreadsheet because you would have different characters and you wouldn't be able to do anything with it. So then we thought, okay, well, since it's Chinese, how about we try Baidu? And Baidu does have a pretty good OCR solution. It's a little bit better. It's able to group certain characters together, but it's also missing some very obvious ones, right? Some very obvious ones. And at the time, we couldn't understand why. And later on, we figured out it was because of the puzzle. We had to split them up. And so essentially what this is saying is, if you have a book that you want to digitize, putting it directly into Google is not helpful. We tried a major OCR supplier in mainland China, and we got this, which is essentially everything grouped into one big blob. Again, not particularly helpful. And also there are some mistakes in here as well. So then we had to devise our own system, and I don't have the boxes there, but essentially you get a very clean data set. And so how did we do it? Well, so we have to create custom OCR for different collections. So let's say genealogies has like, say, 100 volumes. Then we're creating a custom OCR solution for that 100 volumes only. And in order to do it, we had to label over 200,000 columns. It's actually quite a big task, which we did over in Hong Kong. And it came up with all sorts of weird characters. So as we were doing this, what we did was we took AI to automatically to chop them up into characters. That was done by AI. And then we would send them to students to be able to label them. And then we came up with some very interesting cases, like, for example, very blurry cases, and then also some very rare characters as well. And for example, this character. And so we had to actually look it up to see if there was like a Unicode for these characters. And if there weren't, then we'd have to label it as separately. But essentially, what I'm trying to say is that it's not an easy task to create a custom OCR, but it was definitely well worth the effort. Because as they were labeling these things, we uncovered multiple rare characters that we could separate, but we also found a lot of common characters that we could use to train the model. So for example, another one was, I think this is gong, right, for bow. And there's different kinds of calligraphies here. So in the text, we saw something like that, but then we have to train the model to recognize the different representations of the characters so that if the calligraphy is slightly different, it should still be able to recognize it. And so we did all that, and we came up with a model. So I just want to share a little bit about how it starts to learn as we do version 1 and 2, which is as you increase the number of labels, you'll always get a better model. So AI is all about labeling, and then as it sees more examples, it's then able to understand it better. So let's see, this one. Okay, yeah, let's go to the next one. Okay, I think this one is more interesting. Okay, so in this case, for example, if you look at this character here, which I think is Yue, and so in this case, it's written as Lu, but then in this case, it's written as Yue. So essentially, it's able to learn from its mistakes. And what we do is every iteration that we train the model, we have to train it again after we have students look at it. So it was a boring process for around a month, but essentially we went back and forth with experts on these characters to be able to train the model. And now we have a very good model that's able to digitize over millions of pages in genealogy because we went through this process like version 1 and 2, 2 and 3, and so on. And so they had a lot of meetings about very, very specific things about the characters. But then this is definitely worth the effort because now that it can recognize this character, it's not going to make that mistake, and it's going to be much more accurate in producing more genealogies. One thing I wanted to emphasize here is that different collections require different models. So Baidu and Google are one-size-fits-all OCR. But what we suggest is actually you need a custom model to get very high quality data. Otherwise, you don't get any usable data at all. So it's the exact opposite. It's every single different kind of volume should have its own model. But it can be done at scale if you only have to update train a little bit of the characters. So because the model, you'll have like a base model which can understand general Chinese characters, and then for each volume, you just update train it a little bit in order to get highly accurate data. So I'd like to show you the difference between a genealogy project and our Qing Dynasty project. If we look at the number of characters, the frequency of the characters that show up in the data, in genealogy, the biggest character, I don't know if you can see it here, is shi. Shi means lineage, family. And then shi, sheng, zi, essentially everything that's related to the genealogies, right? It's because the terms that are used in the text is genealogy related. So what we see is that the top characters are always genealogy related. In the Qing Dynasty government records, though, we see ren as being the biggest, the most frequent character, and then xian, ji, essentially things that are related to government governance. And so essentially what this means is that the model that was trained for genealogy may or may not be appropriate, like out of box, to be applied to the Qing Dynasty government records because it's trained on different characters. And so what that means is that it's really good at identifying genealogy, but if you put it in a different context, out of its comfort zone, it's not going to do very well. And so this is essentially proof of that. And so when we deal with different volumes, we have to consider the context in which the characters show up. So are they, is the terminology similar? If it's similar, then you can use an existing model. If it's not similar, then you're going to have to train, or I would say update train, a model with additional terminology. So here's an example where we have a base model from genealogy, and we try to apply it to the government records. And just here, it might be kind of blurry. It's Rong'en Hanjun Zhenghuang Qiren, right? And so how it reads is this way. Hanjun, and then Zhenghuang Qiren. So you see there's actually a mini column here, but then everything else is big font. And so you see the updated model, it gets it right. But then the base model, so if we did not update train it, we did not tell it the new terms that it should recognize, it gets it almost completely wrong, right? Rong, well, is that one right? But then, and these are the two because they're really big, but then essentially it just skips everything else. It doesn't understand it. It's never seen it. It just cannot recognize it. So, and also the probabilities are extremely low. And so what we found was that this is evidence of one-size-fits-all OCR is not going to work because you take it out of context, it doesn't recognize it very well. You're not going to be able to get usable data. So imagine you had a database with the base model only, you wouldn't be able to search anything useful. You would have so many missing characters, it just wouldn't be helpful. But the feedback that we got from HKUST was actually had to do with the probabilities. So the team actually felt like that the probabilities should also be included in the database in addition to the character. And that's because the probabilities will tell us something about how accurate the AI thinks the character is, right? So you can imagine these 90% ones, the model is extremely confident that's the character. And so then in that case, your search results it's going to be very confident about those search results. But imagine if you had some very messy data and you applied the model to it, probably having the probability as part of that search engine would be extremely helpful in saving your time. Like, if it's low probability, don't include it in the search result because it's probably wrong. And so that's one thing that we learned from this process, in addition to simply that update training can give you excellent results. And we were very impressed by this one because, so the base model had 200,000 labels from genealogy, but the updated model actually, we only used 2,000 columns. So you can see it's like a very small fraction of the original base model. Just 2,000 columns, we actually labeled it in 2 days, and we update trained it, and it had amazing results. So the only disappointment was this one, which is, I think it's Huang, which is at 50%, but everything else was extremely good. And so this is actually good because we're now hopeful that that means that if a digitization program at a university has a strong base model and has lots of labels, then for the first volume, it'll be extremely expensive to digitize that. But as you digitize the second and the third volume, well, you do the updated model, it becomes extremely cheaper to be able to update it and apply it to different volumes. So of course, that's what AI is about. It's about, as you use it more, the average cost will go down. And that was one thing that we learned from our collaboration with HKUST. And so here's another one. This is a more complicated one. We wanted to challenge the model a little bit. Before I proceed here, I wanted to mention that the model learns from both the visual aspects, so like how the character looks, but also from the context. So if the character is blurred, because it's learned the context before and after, it's able to actually guess what the character might be. And so here's an example of where it understands it from visual. So on this side, the very first character on the top, it's a little bit fuzzy, but it's 主, right? But then we'll see here, is this, okay, yeah, right. And so you see, this is 主. And so when you update train it, it's able to recognize it. But if you use a base model without any updates, it gets something that looks similar, but it's a different character. And that means that it's not going to show up in your results because you're not searching the correct character. You're not searching 主, right? And what's interesting about this is it's actually this part. So do you notice that it's 主是加一级? So you see there's a mini column there too, right? In this case, the base model didn't even know there was a mini column. It just goes from what it thinks is 主是 and then 训 and then 级. So it actually misses one character. So essentially what we do is when we update train, it's able to get those nuances apart from just the characters, even able to understand the mini columns within the text. So that's why we think that update training is a much better solution to digitization, because it's able to tell it all this extra context that it otherwise wouldn't know and look out for. I think, is that completely correct? No? No, okay. Okay, well, that's only 2,000 labels, right? So, but I think the first one was correct, right? So, like the previous, this one was correct. But then when it gets a little more complicated, you need more labels to be able to get it better. But the probabilities are quite high, which means at least we're getting somewhere with that. Okay. And then there's a few extra examples. Again, so actually we stare at this all the time. This is actually what we do on a daily basis, is actually just look at probability results of OCR. To be able to improve them. So what we do with the team is we'll identify the sentences which have very low probabilities and then send them to the group of students to actually look at them. So because imagine if you had 200,000 labels, there's no way that you can correct all 200,000. But what we can do is that we can sort the 200,000 into like the worst ones and the best ones. And then the worst ones being like the lowest average probability, for example. And then we send them back to students to correct them and then update train the model. And so over time then, what you're doing is you're correcting the lower ones, but you're keeping the good ones, and then your average probabilities will get better and better as you go. So it's really a long-term effort, both by the university and also by us, to kind of recursively update train the model. And then these are just screenshots from our system. When we were teaching it how to break down the sentence into different fields. And then that would then create different columns in the data set. And I think, and then this is a genealogy one, but I wanted to show here that you can have many, many fields. So in one of our projects, we had over 30 fields. And again, we trained it over with thousands of parameters to be able to recognize these things. But actually, so this is named entity recognition. Actually, named entity recognition has been around for, I think, around 5 or 6 years now. It's quite popular now in the digital humanities to break down sentences. So what named entity recognition does, let me just go back to this. So what named entity recognition does is you would give it a sentence, and then you would tell it which fields are important and what they are, like what the context. So each color is a different label. We call it a label. And then if you give it around maybe 2,000 or 3,000 of them, 2,000 or 3,000 sentences, you'd be able to train a pretty good model that can actually break down sentences pretty well. So this is after we OCR the content, we already have the searchable text. We're able to apply NER to it, and then that's the final step into putting it into a spreadsheet, which then can be searched. And ChatGPT can do this pretty well, but then it depends on how specific your use case is. But essentially, it's the OCR plus NER is what delivers like a really good data set and very high quality data. Mainly because if NER was very poorly trained, it would not know where to chop it off in the sentence. And then you get certain fields which are chopped off halfway, and contextually they don't mean anything as well. So actually there's a lot of things that could go wrong along the way, but if you put in a lot of labels and also have a system where you can update train it all the time, like identify problems and then update train, then you can always make it better. What I wanted to say here was that it's not like a one-time thing. When digitization is an ongoing process, we've trained models which are over 90% accurate, but let's say we want to make it 95% accurate. To get from 90 to 95 is actually not easy, and it's something that requires years of work. But our take is use the 90% model, apply it to your volumes, and then you have something digital. That's better than nothing, better than not searchable at all. And then you can always update train your model and then reapply it seamlessly back to your data because it's all digital, right? So you just click run, and then tomorrow you have your updated plain text, and then your search results just keep on getting better and better. So it's a long-term process. And I think, yeah, and that's pretty much everything that I have to say today. So thank you. Yeah. Okay, yeah, please, if anybody has any questions or comments, please feel free.
Thank you very much, Graham Sanders, East Asian Studies Department, and that's a wonderful talk. I just had a few quick questions, technical ones, I guess. When you're saying update training, that's just people, human beings figuring out the mistakes and then going back and telling them the model what the mistakes were, right? And then you said it gets better over time, and you have a model that's geared towards a certain text or a certain genre. And can you train cumulatively? Like, so once you build a good model for this type of text, can you then build another type of text on top of that existing model? So now you've got a model that can read a variety of texts, or is it better to keep the models distinct depending on the genre?
Yeah, so based on our experience, it's better to have a base model which is kind of general, but always have an extra layer that is highly tuned to a specific genre, both font-wise, like visually, and also contextually. You know, the sequence of the characters also matter quite a bit. So, so in that, just now I showed the genealogy one. All right, so the genealogy one, for example, actually the updated model contains everything that the base model has, and the base model is completely trained on genealogy. So actually what we did was we actually jumped in terms of the content within the, like the characters within the book are different, completely different. But then it's able to learn the visual aspects of it too. So having a base model is always important. And then for each volume, I would say have like a small update train layer, which could just be maybe 2,000 lines or 3,000 lines, which can actually be labeled within 1 week, actually. But by update train, what I mean is, so the question that us and HKUST were asking were, is it possible, is this technology, like viable, right? Because they first wanted to just OCR everything with Google. And they calculated that that would be extremely expensive if you were to OCR 100 million pages with Google OCR. You're paying a few cents per page, but that adds up. And we were thinking, is there like a more cost-effective solution? And so we found that this method of having a base model, which you do invest a lot in because you're hiring students to label, you have those core labels which create a base model that we'll use for everything. And then for every different genre, we'll have an extra layer. And so meaning that if we had 10 different genres, we would have actually 10 separate models. But then those 10 separate models, 90% of it would actually be from the base model, and then the additional 10% is all different. So you would have, so essentially you would also have to keep everything organized. One folder for the labels from the base model, and then another folder for each iteration of the update training. So yes, yeah. So you just kind of so think of it as like a very modular setup. Yeah.
Yeah, I don't. So, okay, fine. Thanks. Thank you. This was really great and interesting. One thing, I had a couple of questions. One was, so you gave the sort of what you're doing compared to very sort of generic over-the-counter products, Google, right, ChatGPT. I wonder if you could say something about how it relates to, or if you're in discussions with some of the more, say, China studies focused projects along these lines, like stuff that Donald Sturgeon does with CText, or I don't know what exactly is going on under the hood of like the Jiben Guji Ku, but I don't think that it's manual entirely, and it's or maybe it is, but it's pretty good. So I'm curious about sort of, I mean, I imagine it's the sort of genre focus is going to be key, but I wonder if you could say a little bit more about that. And then the other question I had has to do with sort of cursive scripts, which you mentioned in passing. And I know in the Japanese context that for Japanese manuscripts, this has been solved pretty well, but it's also a simpler problem. And I just wanted to hear more about your thoughts in the context of very complex Chinese cursive styles. Yeah. Thank you.
So the first thing was whether or not the database is manually typed out or they have AI, right? Is that?
Well, or just how you relate, because there are other people working on this issue, like for OCR of pre-modern Chinese texts, and then how you kind of relate to those specifically.
Yeah. So so the first thing, so I'm just going to answer it from an angle here, which is we actually talked to a lot of suppliers in mainland China on Chinese OCR, like for this kind of stuff. And the conclusion we got was almost everybody's manually typing it out. In fact, actually, most of our conversations, they would tell us they have factories of people that just look at the book and just type it out, and then they would check it. But well, there's pros and cons to that. So manually typing it out is helpful if you have a small collection, which it would be too expensive to create an OCR model for. But if you're thinking about scalability, obviously AI is going to be more helpful. Now, are they thinking about using AI to do it? Yeah, I mean, they are working on this. But actually, what we're trying to say is that the reason why our method works is actually not just because we're training OCR to recognize the characters, we're also chopping it up into pieces like puzzles. And that's something that most people aren't doing because, so the reason why we do this is actually based on a statistical principle called Bayes' rule. So the idea is if you divide and conquer or you conditional probability, you chop it into a small piece, you're going to be much more, you can train a highly targeted model for that, you're going to be much more accurate than if you're trying to identify characters on a larger plane. So think of it as if I had a big piece of paper and I randomly drop my pencil, what's the probability it's going to hit the same place twice? Very small, but if it's a smaller piece of paper, then the probability to hit the same place twice is much higher, for example. So that's a different method to get at that. At least based on what we know, the existing OCR models, open source or not, don't seem to work extremely well for this kind of stuff. For the Japanese calligraphy, though, yeah, we actually are aware that there's quite a few people working on that in Japan. In fact, just like I think last year, they just published some new models on that, and we've been playing around with that. I don't know enough about that to comment on that one, though. So, but yes, there's some developments in that area, and they are using similar documents as well. Yeah.
Thank you so much. Just have two questions. One is to do with the, I'm thinking about an analogy here. Like the base model is just like you are like a traditional printing house. They created their own, plate, which is not movable, right? And then you have the updated model, which is the movable type. But my question is like, how stable are you confident saying, you buy our base model and you can use it for years? How many years? And then by what time and under what circumstances that you have to kind of really even change the base model to accommodate something which is extraordinary? That's the question one.
Okay, I'll answer that one first then. Okay, so I would say actually the most important thing is probably not the base model, but the labels that go into the base model. So when we employ students to label over 200,000 pictures, that is actually the most important thing, is keeping that organized, because most likely when the students look at these pictures, they'll identify different kinds of calligraphies, different kinds of text, different things metadata that you can slap on the picture and keep track of that. And then the model is just like essentially, yeah, the actual act of printing it. But then what matters is the label management, I would say, is the most important thing. We can always train a model within a day or two, and it wouldn't be too expensive if the labels are already there. And then you get a different model based on the kinds of labels that you feed into it. And so I would say, yes, in theory, the base model can be used for 10 years, 20 years if it's a good model, but you can always make the base model better too by saying, we're going to do a phase 1, 100,000 labels that cover 10 different genres. So you have a good mix. And then we're going to do a phase 2 base model, over the next 5 years. And then we update train that later. But then once you have the phase 1 base model, you can already start doing the different genres already, right? The genre 1 has its update layer, genre 2 has its own layer. And then later on, you can incorporate that into the base model and then keep on growing the project. So I see this as being like an ongoing thing. So I would say label management, absolutely number one. Like the worst thing, I would say like it would be a waste if people did not manage their labels because you put in a lot of effort into it. They're already there in front of the screen looking at it. And if they don't capture that extra metadata, it's gone and you would have to employ them again to do it, and that's twice the cost. So actually our vision with HKUST is that we're thinking that digital humanities programs or libraries, universities, should consider having like what we call like a label warehouse. Just essentially have a server where you keep copies of each label and all the metadata, because that is, well, first of all, you would have spent significant money on employing students to do it, but also that is the key to any kind of good model possibly there. And then even possibly sharing across universities, that would then make a really good model because you would have like a joint effort into doing different genres. So for example, University A and B, they cover 2 different genres, and then they can then blend it together and create a good base model, and they can share their models too. So yeah, that's the answer. Question 1.
Thank you so much. Yeah, it's just I need a bigger picture to understand what's going on. The second question, because I'm a PhD student, I have my own little project. I cannot afford something like this, but I do need to kind of OCR, digitize, find the searchable text, and create a little database. Maybe it's not a small, it's a sizable. So what do you suggest to the student like us? Like, how do we do that? We have to kind of create our own little base model and update it. That would be great, but there's a huge learning curve here.
Yeah. So actually, remember ChatGPT in the very beginning? Actually, there's like some promise there. Actually, I have to say, I was pretty impressed by ChatGPT already, and I would say the hard part is really automatically creating the puzzle pieces. That's actually the hard part. You can actually just use ChatGPT to do. So if you can crop it yourself, like you can chop it into different pieces yourself. So if you can create your own different pieces, and then you send this piece to ChatGPT, most likely ChatGPT will get this right. Like it's very likely to get this right. Okay. And then if the scale is small, let's say 1,000 pages, you could technically do that in like a few weeks, and it would probably work okay. Yeah. But then again, actually, if you think about it, the time spent on that, you might as well just manually type it out, right? So I would say for very small scale projects, manually typing is actually a pretty good solution. So I'm totally not against manual entry, but I'm just saying that for scalability purposes, when people are considering making bigger databases, then there's no doubt AI is going to beat manual entry any day, because you need manual entry to create the labels anyway. So actually, that's why AI is like equal to or greater than manual entry, because imagine you're doing you're manually entering 10,000 columns. You're going to have to do that anyway. But now, if you pay attention when you do it, you can also then contribute towards an AI model one day as well. So it's actually, you actually get more from it than, you're going to spend the time anyway, so might as well consider that option down the road, or keep it organized so that one day it can feed into a bigger project, possibly.
Yeah, just the last question. This to do with the intellectual property, because anything we feed into the AI, I'm not actually the IP expert. But let's just say our department, I'm from study of religion, we do have some kind of historical archive about it, the old stuff from before. So we probably want to digitize it, but there's a lot of work, manual labor involved. If we want to use ChatGPT, this thing will go public, and then I don't know what will happen. So do you have any?
So actually, we did talk a lot about IP actually with many people. I would say anybody who's manually entering anything, that's your own IP, and you should guard it because it's owned by you. You had looked at it, you had taken out the time to type it out. ChatGPT, there's no way around it. So like that's the cost, right? If you want an easy solution out of box, ChatGPT is available, but they're going to take your data for sure. If you don't want to go down that route, I would say just do pure manual entry, and that's like the only solution. Or again, I mean, if one day universities have a really well-developed labeling program where different students are able to contribute to it and also benefit from it, because everybody does benefit from it when you crowdsource their labels, then that's really where, imagine if each PhD student does their part. They label 5,000 columns, and this goes on for years, then that department will have many labels that they can share with different researchers. They can pool all that resource together to create models. So in that case, then it becomes much more affordable and also can benefit students as well. Yeah.
Thank you so much. Yeah.
Quick question. Does telling ChatGPT that it's good at reading actually make it better at reading?
So we didn't do, yeah, sure. We should have tried harder. I mean, I've seen some contexts which are like whole page. Like you can tell it, I think, up to like 1,000 characters or something like that. Most likely what we should have done is tell it a little bit more about what genealogies represent, maybe what kind of characters are the most common, what kind of calligraphy type it is, these kinds of things. But I'm actually a little bit skeptical of ChatGPT, even though it kind of works. The thing is that the question that I keep on getting asked is it good enough for research, which is actually a pretty high bar for data. And we've had many cases where people were very disappointed by ChatGPT. So I've got to manage expectations here. Like it looks like it's promising, and it is, but like I would say, if you told it the same thing twice, it may not give you the same answer twice. So that's the biggest risk of ChatGPT. And there is a way around it statistically. So actually we do have a statistical hack for that, but it's not economical, which is, so how like say a quantitative social science researcher would do this is they would ask ChatGPT the same question 200 times. And that's because at around sample size 200, the t-distribution approaches the normal, so it's like a legit sample. And then they would then take the average results of the 200 times that it gets the same result. And then it would then use that as the final data. But then that means that you're increasing your cost of ChatGPT 200 times, because ChatGPT will cost if you were to do it at scale. It's only free if you're doing it in the browser and you only have like 100 messages per day or something like that. So, yeah.
Hi, thank you. So from my understanding, like the way you recognize the characters are to break the texts into pieces and let the model to recognize each character. So I'm just wondering, how do you reorganize the information? So once the model recognizes the characters, how do you decide like the database scheme and like do we need to have different database scheme based on the text?
Yeah. Okay. So that's something like. Something like this, right? So, so when we chop it into pieces, and how do we piece them back together again? Okay, so for example, in this case, all the big fonts, they're actually different pieces, like piece number 1, piece number 2, piece number 3. But we also have X and Y coordinates, and we're able to train a model that can keep track of it, can guess it. For example, because nothing is exact, right? It's not going to be the border is not going to be exactly the same for every big font. It's going to be moving around a little bit, right, due to human error when they wrote this or when they were printing this. So imagine if the big font was here instead of here. We would then have to statistically guess: does this belong to this lineage, or is it along the side, for example? So that actually requires a different algorithm that we've also developed to piece them back together again. In fact, that's the risk, is that when we do the puzzle approach, you also have to piece them back together again. So actually that is actually also machine learning itself too. We do train a model to guess those kinds of things. Again, from a labeler perspective, they don't have to think about that. They just have to label. They just have to draw the box and just type out what it is. But then we have an algorithm to be able to figure it out, to say statistically where it is, and then make a guess on that, which also could be wrong too, for sure. Yeah.
So you're saying there is a another model that is aimed to find a relationship between the information.
Yes.
Okay.
So this will be an extra layer. So because different layouts will have different interpretations, right? Maybe in this case the interpretation is top down, but maybe in another case it's bottom up, for example. Then then would have to tweak the algorithm to be able to figure that one out. But usually, generally speaking, it's either top down or bottom up or right left, right? There's only 2 dimensions usually. So it's a pretty easy way to turn this on and off. Or actually, if you know a little bit of code, you could probably also do it yourself, given the X and Y coordinates of. So anybody who's studying data science, for example, would probably be able to do this in Python using pandas, which is a popular data science thing. But it wouldn't be too challenging. Yeah.
So is it just based on the spatial relationship, not the the meaning of the?
So this one specifically is based on spatial, but technically you could also include text as well. You know how in social science they teach you how to run linear regressions? So linear regression usually has a lot of x's and it predicts a y, right? So actually that's exactly what's happening here. It's just that if you want to consider both the x and y coordinates and also the text, that's just x1, x2, x3. And then you're just predicting y, which is the result, like the linkage, that's the y, right? So it's very much just linear regression, but just kind of blown up. It's just a fancy, machine learning is just a fancy term for linear regression. Yeah.
Thank you very much.
Hi, me again. Yeah, sorry, I'm not sure if I'm supposed to ask this in this context, but just how is this supposed to work in the sense of an individual faculty member can present you with a project they're working on, or is the idea the university develops a program and kind of their own in-house labelers, and then also with regard to the issue of source of text, like you mentioned Harvard Engine is probably the biggest North American collection of scanned pre-modern text. Is that then their problem, their responsibility to deal with like digitizing, or can individuals or other universities use that?
So everything that we do with universities, it's owned by, well, it depends what it is, but yeah, the university gets a model, gets the labels, all that stuff. Pretty much we just help them process the data just as if we were a data scientist at the university. It's just that we're at Sigtica. But regarding the materials, so usually how it works is the university will provide the materials. And then they'll have, we already scanned so many volumes, like say Harvard Yencheng, and then they'll think, well, okay, we would like a searchable database, and then we just make that happen, and then we hand the database back to them. That's usually how it works, and then also with kind of like a maintenance schedule as well. So, but how can so what we're trying to do is we're trying to advise research programs to think about the labels, because so this actually is a true story in mainland China. Is a lot of mainland Chinese universities, when PhD students first arrive, the first thing they do is they go to the library and they type out 200 pages of text. It's a true story. It's actually, I know a lot of people that's what they do on first day. And so you can imagine, actually, they're already collecting a lot of labels just by doing that. But currently, what they're doing is it's just going towards a docx file, which is on a library server. What we're saying is that, well, if you're doing it anyway, why don't we put it together and train a model with that? So what we're trying to think of is a solution which can seamlessly integrate with their current workflow, rather than thinking about, we're just going to redesign like a whole strategy. No change to research, no change to library science or anything. It's just simply, how about we reorganize it a little bit, and then you get a lot more out of it. So I don't know if that answers the question, but yeah.
But so as I understand, it's really then it's like a joint effort with your library and the university.
Yes, absolutely. So it's more like we advise our partners on what we think would be an optimal strategy for them to build these models, and yeah, they own the models. Yeah.
Just to answer to the question, it's not really an exact answer, but Guenther and I, we chatted yesterday a little bit. That, for example, we have a lot of verbooks here, and we have been digitizing a lot of those. And we made them available open access through Internet Archive and some other channels. And now Internet Archives, they are using Tesseract, open source OCR, which is not really that accurate for Asian languages. And previously they have been using Abby Fine Reader, that was even worse. So, and we had some chat about OCR accuracy, and potentially what we can explore is that we digitize with Internet Archive because that is our partner for digitization here. But Internet Archive reach out to either Guenther or other organization where they might have a appropriate language capability models or manpower who can provide the expertise. Like for example, right now we have we are planning to digitize Tibetan collections that we have here in our library. Internet Archive, the Tesseract software is not really working properly for those Tibetan collection. But BDRC in New York, the Buddhist Center, they have developed their in-house OCR software, which has very high accuracy. So Internet Archive is willing to work with BDRC for our text. So I think that's really the model that we are trying to explore.
I think. Yeah.
One more quick technical question. You had probability ratings for OCR characters for their accuracy. Do you also have them for the parsing that the NER does? So that like we think that we parse correctly, and then if it's low probability, someone will go check that.
Yes. So what we did last year, we did not, but now we currently do. So it has to do with the model architecture. So yes, now it is possible to do that. And actually, we're literally doing that as we speak right now. My colleagues are looking at these kinds. So the thing is, I think the main concern with all our partners is always how do you find the low probability problems and fix them. So there's a catch with NER though. So with NER, let me see. Okay, maybe this one will work. Okay, so the problem with NER though is that you have to break them into different fields, right? And so we can have probabilities on very specific fields. So for example, Anhui will know if it's a 50% or a 60%, or also what the alternative is. But in terms of alternative, it's alternative column. So like maybe this was misplaced in this column, it should really be in this column. So we'll be able to know the alternative and also the probabilities of those alternatives. But then what we won't know is like, say it should be these two characters together, not these two, for example. We can't see that. So it's already, given that it's already been broken up, what's the probability it fits into each column? So.
Actually, I'm just curious about that. Is there any approach to scan and make the data coding for the map or this kind of other like paintings in the, for example, like chronography, this sort of stuff?
So actually, someone did approach us with a map. It wasn't just like one map. It was like a thick book. I guess maps come in thick books, and there was like 200 pages in them. So the problem with, in theory, is it possible? Yes, it is possible. So what they wanted to do there was, they had a map of, I think it was some region in China from 1,000 years ago, and there's characters on the map, right? It shows like, oh, there's a little mountain here, and it's called something, and then there's a village, and there's like a picture of a village, and then it's called something else. So we never took on that project because we think that one's actually much harder than the ones that we're already doing, mainly because there's a lot of stuff that could possibly confuse the model. There's a lot of pictures and other things which it could mistakenly think is a character rather than a picture of a village or something. So, and also another thing is the scanning. So if we were to do it, how we would do it is we would take a big high resolution picture of a map and chop it into different quadrants, and then throw that quadrant into the algorithm to identify, say, characters or some sort of picture. But the problem is also stitching them back up. That's also could possibly be difficult as well. So, but in theory, yes, this technology, it can actually do maps too. That's true. Yes, we just have no experience with that yet.
Thank you.
That wraps up our session. And thank you so much to Dr. Guenther Lomas. Thank you. Thank you so much. Thank you so much for the insightful and the informative talk today. And thank you for coming. We have delicious food at the back, so please enjoy and continue to have a conversation with Guenther. Thank you.